In this session, we're going to put into context some of the concepts and some of the practical aspects of doing data management. And what I have done is I have taken a case of a piece of research that has to do with managing fall armyworm, and I expect some of you have come across the fall armyworm with an agroecological approach. So a little bit of an introduction for you. So the fall armyworm, and there are some pictures of it there on the screen, is a pest that has recently become a problem in good part of Africa. And there is a research project that is interested in understanding the extent of the damage to cereal crops that is produced by the fall armyworm, and finding agroecologically based options for managing the problem. This project has put in place a series of research activities. The same way as you as students or as researchers within projects carry one research activity or several. The project has many that are somehow interconnected. The project is working with farmers, and there is a collaborative process of trying to understand the problem, the extent to which it is a problem, and what can be done. And includes activities like farmers monitoring fall armyworm in their own plots. They have a farmer-led experiment testing different management options, and they have researchers' observations from their field trips as part of the research activities. They have also had a brief questionnaire about farmers that are participating in the research. These are farmers experimenters. And they have a joint process of searching for pathogens and natural enemies of fall armyworm. So these are 5 of the activities that I have selected for this presentation. And we say it is with an agroecological approach. So I want to put this into the agroecology context. I've copied this picture from the diagram that represents the HLPE 13 principles of agroecology. I remember that earlier on in one of my presentations to you, I used the 10 FAO principles. So today I am using the 10 FAO elements, and now I am using the 13 HLPE principles of agroecology. And I have highlighted the elements that the project is explicitly touching on through these activities. The first one is participation, and it is a process of joint research between farmers and researchers and research institutions with an aim of co-creating knowledge. So that's fundamentally different from other types of research that we have done in the past. It seeks understanding synergies that are going to help in managing the problem. And it's not only looking at the problem itself, but at the system that generates the problem and that can help solving the problem. And that is the agricultural system that might help us over the long term look at options for a healthier and more sustainable way of producing. And I am using sustainable here not only from the financial point of view. It emphasizes biodiversity as one of the elements that they seek, and has in particular in particular in relation to the experiment that they are working on, an emphasis on soil health. The Spodoptera, the fall armyworm, has one of its stages on the soil, and they are looking at soil management practices to try to see how they affect the population of Spodoptera. Is combined with input reduction because of the negative consequences that it has to natural enemies. And it is looking in general at the land and natural resource governance. So it is an agroecological approach for those reasons. And I wanted to emphasize that aspect because often agroecology is associated with good practices in the farm, and it is important that for us agroecology is understood as an approach that is principle-based for a healthier and more robust agro-food system. So that's the context in which this is happening. Farmer monitoring data was one of the first activities that it's the first activity that we're going to look at. And I am looking at how they are managing data. So farmers involved in this project can identify the eggs, the larvae, pupa, and adult of Spodoptera. And there are some pictures of those different stages of the insect for you if you haven't seen them before. And what happens is that researchers, farmers are keeping a notebook where they note observations that they have of the insect. And researchers go to and visit the farmers, and the farmers share with them their notes. The researchers then transfer some of that information into an ODK form during those visits. Farmers are encouraged, and this is what they record, to register findings in each of their plots as many times as they find the insect during the whole duration of their maize season. Okay, that's important. What is registered by the farmers and how. And here is a note made on the 14th of April of 2021 by John Quijona in what he calls his plot number 1, and it's near the house, and the crop that he has on it is maize. And it says, I planted my crop at the end of March with seeds that I obtained from my brother. Little description of that. And then about the fall armyworm, I found a few moths flying in the field when the sun was going down around 6 p.m. But I could not see many. And then there is another note on the 25th of March 2021 in the same plot with the same crop, not surprised, with a comment that the plot is looking beautiful, and found some eggs of the fall armyworm like the ones I saw during whatever it was. And I did take the next photograph. Okay, so this is the type of data that the farmers are keeping. So if it was up to you, what variables should the research collect in their ODK forms? That's a question I would like you to answer. menti.com and to use this code when you go there. And I just wanted to make this a little bit more participatory. And if you go there, you can answer the question directly. What variables should the researcher collect in their form? And as you do that, I expect we will be able to see your responses appearing. Comes. Tell me if you're having problems. Pest, crop, date, and farmer. Thank you. More. We've got 2 people, me is 1, and 1 contributor. Let's see if we can get this to at least 10. Okay. We've got 3. You can have as many contributions as you want. It seems that date and plot and farmer, X appears once. You see this farmer name is several times. Now you're saying that there is someone who mentions metadata, observations, crop codes, the village, the date. Any more? Even if you think they are the same. The damage caused by the pest, the eggs, the area, got 8. Two more and we move on. And I will show you what we have in the data. It is not terribly complicated. So thank you for those of you who have shared. Oh, we got a bit more. Okay. Thank you. So
we are still trying.
Say that again, please.
Okay, we are still trying. It has given me another. Trying.
Okay. I'll give you 1 more minute. So data planting, observations, codes for something or another, village pest. So we are having where, we are having who, we've got a suggestion of the damage caused by the pest, plot location, area, plot, the crop, the eggs, the farmer. Okay, so this type of decision needs to be made as part of the research design, and we will see what decision they made and how that was then moved into a data set. But remember that, thank you, someone wrote directly. Remember that we have, just try to move this out of the way. We have here, I need help removing some of what has been written on the screen. Here, thank you. So they have included the date of the observation, the identification of the plot, the description of the crops in the plot, where the insect was seen, it was seen flying, the stage of the development of the insect, it is a moth, and how widespread was in the plot, And the objective was to monitor how the fall armyworm was appearing in the plot. So this is what was done. They set up an ODK data entry form, and I took screenshots. And there was a farmer ID. There was a date recorded. There was a plot identification. There was a space for the crops in the plot, and it's a description of the crops. There was a selection of what was the insect found. Oh, no, where was the insect found? The soil, the stem, the leaves. And notice, I don't know if you know about this, but these are little squares. That means that they can select more than one at a time. And what was the stage of the insect? Egg, larva, pupa, or adult? How widespread it was? Very few, rare, in many places, everywhere. And that is one only. And farmer comments. And this is a decision that is made and determines what we're going to record. We might agree with it, we might not, but this is what was decided to collect. And there is a process of transferring data from the farmer's notebook to a more structured, organized data set. And that is part of this flow of data that is important in quality assurance. And what you see here is what I call the raw data. This is the data that came from ODK into my Excel spreadsheet when I downloaded some of the data that had been collected. And because it was very long, then I cut it into pieces, okay? So ODK give us a start, end, and today as meta data on when this happened. There is a farmer ID, and there is a code here that was created as a unique identifier of the farmer by the project. There is a farmer observation date. This is when the data was collected, the observation was made in the field. There is the identification plot, and it was only one number. Crops in the plot, maize. The next variable was where was the insect found, and it was found in different places. Where then this same information, where was the insect found? If it was in the soil, in the stem, on the leaves, and the head, or in the air, it is here as a variable, but it's here as 0, 1s, and ODK prepares this automatically for us. So it gives us the information in two ways, in a single column in text and in separate columns as 0, 1. Now you notice here that column K has a number 1 when it was found on the leaves, and number 1 when it was found on the leaves, and that's indicated by the heading. And then when it is the cob of the head, it has a number 1 here and 0 everywhere else. This is a standard way of registering information that comes from multiple possible answers. And the same happens with the next question: what was the stage of the insect? It comes as a single column here, and then it is split into 4 different 0, 1 columns. And how widespread was the insect? Very few, rare, many places, everywhere. That comes as the text directly, and then the comments come as text again. And finally, there is a little bit of more metadata that is generated by ODK. This is data that I call raw data because I have done nothing with it. This is what ODK gives me, and obviously there is repetition, and there are some columns there that I am not interested in. Then the project decided that they were not going to use this as their data. This is only a stage on the data process, and they were going to create a new spreadsheet where they had the information in different order, and the data is transferred from the ODK Excel download to this one here, and is the farmer ID, the first one. I've colored it differently because this variable here has a totally different function as the rest of them. The ID variable identifies these rows. And then it gives the f of date. What is f of date? Luckily, they have provided us with a dictionary that says f of date is farmer observation date, perfect. F of date DD, farmers of observation date, day, month, and year. They split it into 3 different columns. Very likely because of the problem of transferring dates between program software and software. And then there's a plot ID, and then they kept the 0, 1 columns for the where the insect was found, the stage of the insect, and the level of spread. And then there is a final column, F comments, farmer comments, and those are the observations. Notice that they created a dictionary where there are codes here, and 0 means no, and 1 means yes for these variables here. And 1 means rare for the insect spread. Oops. And 2 means in many places, 3 means everywhere, and 0 means very few. And that is the interpretation of this. Okay, so now you can see how the transfer from fieldbook notes to ODK to final data set happens. And this is something that is quite normal. Okay, I would like you to now propose 3 ways to prevent errors for this activity. And please put them on the chat. Where do you think errors can happen and how you can prevent them? Peter says transcribing from field notes into ODK. Yes, that's a very likely place where errors might happen, and especially where incomplete information might happen. Aldo says in writing the date. What sort of problem, Aldo, and how do we prevent it? So we proper and careful recording of field noted, okay, and frequently visit the plot to make observations. So we need to manage that process, probably give a little bit of feedback to the farmer on the notes, take advantage of the opportunities to agree when the next 10 will be that we would come, and possible problems that we have detected, learn together with the farmer. We might put control limits in another case, okay, for the dates, yes. Okay, so that was 2 minutes. But remember, you need to look at the process to identify where the quality assurance will be important. Let me continue. Then we have a brief questionnaire about farmers participating in the research. This is the questionnaire: farmer name, farmer ID, district, the GPS is here with loads of decimals, number of plots planted with annual crops by that farmer. So Rose had 3 plots, and it has plots, crops, and problems with the fall armyworm. So in the first plot, crops planted in 2021, she planted maize. Did she have problems in 2021 with fall armyworm? Yes. Did she have problems in 2020 fall armyworm? Yes. She had 2 more plots, one with maize and cowpeas in intercrop, where she had problems last year, so this year, and had problems in the previous year. And she has a maize and pumpkin intercrop with no problems yet in 2021 and problems in 2020. It's fairly simple. It's a fairly simple questionnaire with information about the farmer, information about the plot, and information about the crops, and information about when they had problems in 2021 and 2020. So this is how the questionnaire was converted into tables. There was a farmer table, and the farmer table took the first part, the farmer ID, the district, the longitude, the latitude, and the number of plots. This went into one plot. Then they decided to put the plot level data into a different table. And they had in that table the farmer ID. Why? They have the farmer ID there to be able to link it to the farmer data. And you remember we talked about key ID variables. So farmer ID is a key ID variable because it allows us to link data from farmer level to plot level. And then there's a plot number that identifies the plot. And then at this level, they put 2 columns, Fall Armyworm in 2020, Fall Armyworm in 2021. And that corresponds to this column in the questionnaire and to these 2 columns in the questionnaire. Then they decided that at crop level, they were going to put the farmer and the plot and the crop that they had in that year, in 2021, in that plot. And in order to bring that data together, they have 2 key variables, farmer ID and plot number. And you decide how you're going to organize your data. So these are the decisions that they made. Let me move on a little and take the form again and ask you a question. For the farmer ID, how many lines will there be for this questionnaire in the farmer level data? And you can type it on the chat. How many rows will we have in the farmer table from this questionnaire? Remember that the farmer ID level has the farmer ID, the district, the longitude, latitude, and number of plots. How many records? Maurice, you say 5 records on that table. 6 from the number of Aldo, it is not for all of them, but for this, from this form here, from the form that you are seeing on the screen. And first of all, thank you, each one of you, for your answers. I'm so pleased that you are writing here. I'll tell you what they did, and then we can go back. For rows, they have 1 row. They have her farmer ID, that was A41 BUM, finishing 3443. A41 BUM, finishing 3443. That number here comes from this entry here. And then the district, Bamula, that entry comes from there. And then the longitude comes from here. And then the latitude that they put, finishing 1161, they have here 1160, and they got rid of the decimals. That's an interesting decision. That's how it's 61. And then the number of plots, 3. From this questionnaire, the farmer ID table gets 1 row that includes this information. Okay. Is that clear? Any questions there? No questions. So let me go to what you think, what you know, I believe, is the next question. So we move to the crop level, where they have the farmer ID, the plot number, and the crop name. Okay? So that is this part here. How many rows will rows contribute to this table? Anyone suggesting? This is a little trickier than the previous one. 3. Okay? One could say 1, 2, and 3. That would be a possibility if we put 2 crops in the same row, because that happened in the second plot, and maize an intercrop. I will tell you what they did. It could be 3, absolutely. But what they did was the following. They said, the farmer, and this is Rose's farmer ID, remember, finishes in 3443. She's got 3 rows, sorry, crop level. The farmer, she's got 1, 2, 3, 4, 5 crop level data. Why did they put 5 crop level data? Because they say, well, a crop can have more than one, sorry, a plot can have more than one crop. For example, plot number 2 had maize and had cowpeas, and they decided to separate the crops into different rows. And that's why they call it the crop level data. So they had 1, 2, 3, 4, 5 rows for rows. And they come from here. Maize in plot 1, maize in plot 2, cowpeas in plot 2, maize in plot 3, pumpkin in plot 3. And that yields 1, 2, 3, 4, 5. And finally, at the farmer level data, where it's farmer ID, plot number, and whether there was fall armyworm in each of the years, they end up with the following number of cases. Here, farmer ID, rows, plot number 1. She had problems in 2020, had problems in 2021. And in the plot 2, different conditions for yes in 2020, yes in 2021, plot 3, yes in 2020, no in 2021. And so the whole questionnaire gets transferred into 3 tables that have this structure. The structure is not unique. It can be arranged in different ways, but that is the sort of decision that you as a data manager have to make. And you learn what decisions are best for different purposes. But it's not easy to put this set of questionnaires in a single table. And the question that leads that decision is, what should be unique about each of the rows? So, what is the relationship within the tables? Notice that Rose, who is here the farmer and has information on these districts, on the district and GPS and number of plots, at the plot level ends up with 3 plots, 1, 2, and 3, where the conditions for the fall armyworm are recorded. And each plot then has different number of crops. And you can see that crop 1 has 1 crop with one crop, that's maize. Plot number 2 has 1 crop, that's maize. Plot number 3 has got 3 crops, cowpea, maize, and pumpkin. And that happens in different years, but plot number 3 has had these crops. Therefore, the use of IDs and key variables, the concept of tables, and the transfer of information from one type of recording media to another, and the transfer from raw data to final data set for analysis. The actual file, I cannot open the file. I knew it was going to happen while I was working with you. So I have it here. Let me just open it. The files are in a single folder here, and that is the farmer monitoring data. Okay. No, that's not farmer monitoring data. What I want to show you is farmer questionnaire. Farmer level dictionary is here. Farmer level data is there. Crop level dictionary is here. Plot level data, dictionary, plot level data is here. Crop level dictionary here. Crop level data there. Okay. Then we have farmer-led experiment. And the farmer-led experiment is interesting because the project has 4 treatments that are standard, and the farmers can choose to have them or can choose not to have them in their farms. But the farmers are allowed to bring their own treatments and options for managing. And so this is researcher-driven. This is farmer-contributed. And participatory research has to do with negotiating this type of thing. And in this case, the research team has allowed farmers to include their own treatments into the process. And it's one of the interesting things will be to explore what are the options that farmers are proposing compared with the options that the researchers are proposing. Researchers are proposing options that have to do with soil management and with intercropping. Farmers are proposing use of repellents, chemical insecticide, use of ash, so a substitute for an input. Here there is a different crop with some intercropping and insecticide. Here is a farmer that is actually having a rotation, a much more sophisticated way of managing the crop. And so the experiment is not only the result of the experiment, is the contributions to the definition of the experiment by the farmers. And they had a data entry form in paper for the farmer to put their data. And the variables that are going to be measured are very few: treatment, plot number, date, the yield, and the damage caused by the fall armyworm, with a definition of treatments by the farmer and a scale of damage given here. And that is all the data that is to be collected. A little bit shocking for those of us who grew up at the time of experiments in research stations where we measured loads of variables at different times. And it's like an important contrast in the type of experiments that you run with farmers. And the structure here is that we have a plot level data because the farmers put the treatments in their own plots. So which farmer, which plot, which treatment was applied, what is the yield and what is the the damage that is produced, and the treatment level, because the treatment needs to be defined. What treatment number is used, and what is the description that is attached to it. See if this wants to work. This is working. Treatment, this is the dictionary for the data for the treatments, for the experiment. Farmer ID, treatment, plot ID, yield, and damage with the variable names, the units of measurement, and in this case, what each of the numbers represents. And the treatment codes are here. And this is the treatments that were used and how they are represented in the data so that you can understand it. I have changed colors here of the columns because this is the key variable. These 2 columns are variables that have the function of describing the experiment and without which I cannot analyze it. And these are the observations, the results of the experiment. And there is another activity. And I've got 5 minutes to go through this one. A search for pathogens and natural enemies. And what happens was that farmers were given in small containers to collect dead insects in whatever stage, but at these fall armyworms, it says here, that they find in the fields, provided that no insecticide was used. The farmer kept a record of the date when it was found, and they gave that container to the researcher when the researcher visited. The researcher made an entry in an ODK form and took the container to the entomology lab, where the insect was, where the dead insect or larva was identified, and tried to see what was the cause for the death of the animal. And this is because if something killed it, we will want to know what killed it, so that we can potentially use it as a natural enemy. So the data entry form the data has a farmer ID, a container ID that was scanned from the container, a field date, month, year, and day for when the larva was found, when it was collected by the researcher, and who collected it. So there is a researcher ID here. And this is what it roughly looks like once it has been transferred from ODK into a clean data set. Researcher ID is codes. And there is also a lab form where the barcode of the container is scanned. The date when the farmer found it was entered, and the description of the lab analysis was registered, and the lab researcher was identified. This is the dictionary. These are the data. Container, date in 3 columns, the lab result, parasite Hymenoptera, inconclusive, fungal pathogen, inconclusive, etc., and the research ID with codes. Interesting, they decided to have the research ID as a table, a separate table with the research code, a researcher name, and the researcher type. So in this last one here that comes from the lab, we should have 10 and 11 as codes. And in this one, we should have codes that go from 1 to 9, because that is the way that it is classified in here. And they have a different relationship. Here, the key, the really important one, is container, although they kept farmer ID. And the container ID allows you to match the information from the field with information from the lab, and they are informed by the table with the ID. Finally, we have researcher's field notebook. This is a picture of a researcher field notebook, and this is where the researcher keeps observations. And it says researchers will systematize their observations and share them during a workshop where the analysis of the trials and farmers' observations will be brought together. And then it seems that we have the farmer and the farmer ID at the center of the data structure. We have the farmers monitoring data with the 3 levels. We have the experimental data with the 3 tables, the experimental data with 2 tables, the pathogen data with 2 tables here, plus the small table that is, I would call it a lookup table for the ID of the researcher, the book that the farmer keeps, and the book that the researcher keeps. For me, it's interesting that it is a data managing process that is multi-level, that is multi-agent. The data management system, data management the strategy matches the system-based approach that they are using. It brings qualitative and quantitative data together. It involves loads of people in the process, and it's complex. And for me, quality assurance is key. And so this is the description of the case study that I wanted to share with you.